Hey everybody, this is Nicholas, and we are going to be looking today at AMP HTML, an overview of AMP. So AMP stands for Accelerated Mobile Pages, and this is an open source project sponsored by the large players on the web, including Google. Google is a big sponsor of AMP. And AMP HTML is perhaps the biggest change since the HTML that we know that evolved since the 1990s of basically building the web. It has had multiple iterations, the latest being HTML5. HTML5 has brought lots of improvements in terms of speed already, but also capabilities to run things more lightly and more nimbly in a web browser, replacing, for example, Adobe Flash, a very heavy plugin by Adobe to run videos. And now you can run videos in HTML5 much faster. But then AMP HTML is a new code base that takes it one step further, maybe two steps further. And we're going to be looking at that today. So the first thing to consider is that AMP is basically a parallel evolution of HTML. It cannot replace immediately standard HTML. So what's happening is that websites have two URLs. They have their standard URL path, the URL of your website, the URL of your website's web pages with its permalinks. And then there is an AMP page which is appended /AMP at the end of this URL, which takes the contents, strips everything, and basically creates this super fast minimalistic AMP page. So the design goal of AMP, as its name implies, is really speed. It really is to strip everything in a web page that slows down the load time of that page. And that can be executable code, or it can be simply the size of photos that potentially can get resized and lighter in terms of bandwidth consumption. At the same time as there's an AMP page, Google is going one step further, which Google is creating its own, yet even lighter version in some cases, only in some cases, of AMP HTML pages called AMP Lite. And you'll see that one day in your web browser. If you look at your Google Analytics, you'll see some pages that are called AMP Lite. And AMP Lite is basically even more stripped down. Google removes even more code from the page without altering the way that it looks. And it makes photos also even lighter by lowering the quality a little bit more without degrading the user experience. That's particularly useful in many places of the world, like South America, Asia, Africa, or even in main markets like the US or Canada or Europe, where you're far away from a cell tower, you have very, very light internet connection, and you're trying to get some content. And the only way to get it is to load an AMP Lite page. So Google will detect when you do a search what the bandwidth is that you have on your browser depending on your connection. It'll quickly look at your phone's specs, and if you don't have enough memory on the phone, it will load an AMP Lite page because it will detect the memory footprint on your phone. As a result of speed being first in AMP, design takes a second place. So AMP pages, and we're going to take a look at this, don't look quite as nice, don't look quite as polished as standard web pages. And eventually it'll get there. But as of today, the focus of AMP really is on speed with no compromise. And when there's a compromise to make, the compromise is made on the design, the prettiness of the templates and of the page. AMP is also a first step towards a new category of apps called progressive web apps, abbreviated PWA. Progressive web apps are the next iteration of mobile apps that will also blend into the desktop at some point. But the gist of it for a progressive web app is that you can now run an app experience from the mobile web browser. Instead of having 100, 200 apps on your phone that you install one by one, the app is run from the browser on your mobile phone, which means that when you favorite an app, you don't download the whole app. All you download is the URL of the website. It gets on your phone, and then that website becomes available offline. It has a shell, and it runs AMP pages, interestingly, which is why basically the two are tied together. So if we look at our diagram of connectivity to the internet, typically, as we looked before, you get to a website, it checks for the DNS, it goes, if there is one, to the CDN, the Content Delivery Network, which is a local cache near you of static content that can be delivered very quickly back to you as the user. If the CDN does not cache the content, it goes to the server. Sometimes a load balancer first, then compute instances, which is really the web server, and then the backend database if there is a dynamic content and data to look into. And then to render the page, it is going to come back. AMP basically simplifies all this by having fewer connections to make, requests to make into the server and into the database. But also Google has its own cache. Google is putting servers all over the world near the users, just like a CDN, in addition to CDNs. So if your CDN caches your AMP content, your content will be cached twice. It'll be cached by your CDN, and then it'll be cached by Google's, let's call it a CDN also, Google's AMP cache. And the Google AMP cache is going to serve the web page from a search result extremely fast, and it will guarantee that the content is nearby. Meaning that even if you don't have a CDN, you will have one with Google AMP because you have an AMP page. So what are the implications of AMP? The first thing to consider is that at the same time as AMP is coming out, something came before it. Facebook is taking a larger share of the internet. And when you browse on Facebook, Facebook has developed its own version of HTML, interestingly. Facebook has developed a version of HTML that takes a copy of your content as a web site owner, and it strips everything that makes it slow, and it basically caches it on Facebook servers, and they call it a Facebook Instant Article. You might have seen that. You go to the Facebook app on your phone, you see this thunder icon, and you get to the content very quickly. It loads instantly, hence its name, with Facebook custom HTML code. So AMP, sponsored by Google, is very much a response to the Facebook Instant Articles. And you can see that these are two competing formats and two alternative solutions to make the web faster. Eventually the users are going to win. Whichever format is going to dominate, and maybe the two will coexist, and maybe there'll be a third. And you can see that the theme right now on the web is the realization that the mobile web experience has been very slow. The bandwidth has gotten better on mobile phones. The phones have gotten much, much, much stronger, faster, more powerful, more memory, more CPU. And even with all that progress in cell phone technology, when users, as of 2016, 17, when users browse the web, it's slow. We scroll on a mobile phone and we can't scroll because the page is still loading. It's making a bunch of calls with JavaScript ads, and this is slowing down the experience, and it's frustrating users. So Google and Facebook are all about accelerating all this. Today, these two formats are limited to posts, not pages. So if you are familiar with WordPress, content management system, you have a concept of a post, which is typically a blog post, like a news article or a recipe. And then pages are more longer living or kind of aggregate series of links, but a different type of page, and they're called pages in WordPress. So they're not supported yet. They're not supported for Facebook Instant Articles. They're not supported for AMP. It will come over time. Implication, as we said, is that the speed of light is going to always be the limit. When we go from America to Europe, it has to go across the Atlantic for, first of all, the ping, and then it has to come back, so it has to do the distance twice. And that has latency. The benefit of having a CDN with Google caching the content, and eventually perhaps also Microsoft caching the content and other search engines caching the content, is that's where the competition happens. The AMP page is a unifying battleground, and then the caches are where each of the search engines can differentiate. Initially, the search engines like Google have said that there will be no ranking difference in search rankings. That can be true, but eventually you can look at an AMP page as a faster version of the web, and if the search engines look at the page load and the page speed as a ranking factor, not because they're AMP, the fact that they're AMP and they load faster will eventually move those rankings of sites that load AMP. And then, of course, starting now, it's already available. You can see the Thunder icon on some websites, you cannot see on others, and the users quickly make the difference of what loads really, really fast. All of this is evolving. We talked about the progressive web apps. We talked about the code base, which is really towards speed first with minimal design. There's a roadmap. You can look at AMP roadmaps, and it's worth starting now if you're just getting into AMP pages, because you'll learn about it. So let's take a quick look now at, well, actually this website and the first iteration of AMP pages. It will evolve like everything. On the left, you can see the standard HTML website with its URL path, very classic. And on the right, you can see the AMP page. So you can see that it's a duplicate that's been made for AMP only. The URL has the /AMP appendix that is like that on all AMP pages. And from there, you can see that, let's look at a browser. In the browser console, you can see that on every Chrome browser, you can do this inspect function here. That inspect function will show you code, it will show you the network timings, some errors, and an interesting tool is GTmetrix. So GTmetrix looks at your web page when you load it, and it looks at all the things, the waterfall of your web page. Here you can see that it took 3 seconds, a little bit over 3 seconds to load for the standard page, half a meg, and 57 requests, which is pretty standard for the web. Now we look at this page on its AMP version, and look, from 57 we are down to 6 requests. The reason why AMP is so fast is because it minimizes the number of requests to your server. It minimizes the bandwidth. You can see that we went from 497 and 57 requests to 108 kilobytes, and the page load time as a result has decreased dramatically, getting an A score on both of these metrics, which means that on a cell phone, when you're far away, it's going to load instantly. So that's about it for this overview of AMP. There'll be other posts that we'll talk about the AMP ads, we'll talk about how to make an AMP page technically, but for now this was just an overview. Take care.